Hi everyone. Today I'm going to begin Unit 6, Chemical Reactions. This is actually my favorite unit in chemistry because we get to do a lot of labs in this unit and see a lot of cool reactions. Alright, basic information you should know getting into this unit. First of all, what is a chemical reaction? You may remember from Unit 2 when we were discussing matter that we talked about the difference between a chemical change and a physical change. So remember that a physical change does not change the identity of a substance. You're just changing how much of it you have, or maybe the state of matter that it's in. So when a solid like ice melts into liquid water, that is a physical change. It's still made up of H2O. But a chemical change or a chemical reaction is when you create a new substance that wasn't there before. It has new properties. And that change, that reaction, cannot be easily reversed. You can't easily go back to the original reactants. So when you have a chemical reaction, new substances will be produced, and you'll be able to tell that something happened. There will be a physical evidence that a chemical change occurred. And this is just a list of some of those evidences that you'll be looking for. Light produced, a smell, gas. If you see bubbles form, that's a gas being released. If the color changes, or the temperature, if it gets hot or cold, exothermic or endothermic reactions. And one more that's not on here is if you ever see a clear substance all of a sudden turn cloudy, that means that a solid has been produced, an insoluble solid, meaning it can't be dissolved in water. And we have a fancy term for that in chemistry. That's called a precipitate. So precipitate formation is when a solid is produced by a chemical reaction. All right, so some things you need to know when we write equations is that your reactants are always your starting materials. It's what you have to begin with, what you mix together. And your products are your final materials. That's what you end up with after the reaction occurs. So for example, if you're baking cookies, all of the ingredients that go into making that dough would be your reactants. So the eggs, the sugar, the flour, but your final product would be the cookies after you've baked them and the reaction has occurred. Now, when we write a chemical equation, we're going to separate the reactants from the products using an arrow, which is called a yield sign. Now, the yield sign just means the reactants have been mixed together to produce or to result in the products, which will be on the right-hand side of the arrow. So the reactants are on the left side of the yield sign, and the products are on the right-hand side of the yield sign. So just to make sure that makes sense to you, in this equation it says, is barium chloride a reactant or a product? So at this point you should know how to name compounds, and the only two compounds in this equation that contain barium are this one and this one. And this is barium nitrate. This is barium chloride. Since barium chloride is on the left-hand side of this arrow, the left-hand side of this yield sign, it is a reactant. In example 2, the question says, in the reaction above, is sodium hydroxide a reactant or a product? So you have sodium by itself here, and on the right-hand side you have sodium hydroxide. It's one of your polyatomic ions. So since sodium hydroxide is on the right-hand side of the arrow, it is a product. Now, different types of equations that you're going to encounter in this unit. You're going to encounter word equations. So that would be taking into account the reactants in the equation, the products, and reading those out like a sentence. So sodium and magnesium chloride react to form sodium chloride and magnesium. Well, normally what we do is we take word equations and we convert them into skeletal equations. In other words, we take those words and turn them into formulas. So sodium is Na, Magnesium chloride is an ionic compound, so don't forget what you have to do with those. You need to crisscross your charges. So magnesium is +2, chloride is -1, so I cross my 2 here. And then where it says reacts to form, that's where you're going to put your arrow. And on the product side, you have sodium chloride, NaCl, +1, -1, those cancel out. And is your plus sign, magnesium metal. Now notice that skeletal equations are not balanced, meaning you don't necessarily have the same amount of atoms on each side. So you might notice that on the left side we have 2 chlorines, and on the right side, the product side, we only have 1 chlorine. So this is a skeletal equation. It is not balanced. So that leads us to our last type of equation, and that is a balanced equation. In a balanced equation, all the atoms of the same element are equal on the reactants and the product side. Now, how do we make them equal? You can't adjust the subscripts, these little tiny numbers. The only thing you can do is add coefficients. So you'll notice what I had to do is I had to put a 2 in front of NaCl. But when I did that, that gave me not only 2 chlorines, but it also gave me 2 sodiums. So I had to put a 2 on the other side in front of that sodium. Now that might not make a ton of sense right now, but we'll do plenty more examples as we go along of how to balance an equation. So just to summarize, word equations is an equation using words. Skeletal equation is an equation using formulas, but it is not balanced. And balanced equations mean that you have the same number of atoms of each element on both sides. So, speaking of balancing equations, how do we do that? Well, there's a few rules we need to know about before we jump into some examples. This first rule I've already mentioned, you cannot change the subscripts. Once you have written the formula, once you've crisscrossed your charges, you cannot change those. So remember, subscripts are these tiny little numbers out to the right of the element. What you can do is you can add coefficients. You can add those big numbers to the left of the formula. And this last bullet point is explaining why we do that. It all has to do with the law of conservation of mass. We can't create or destroy matter in a chemical reaction. So if we begin with 2 hydrogens, we also have to end up with 2 hydrogens. In this next slide, you can see just a visual of what it looks like after we balance an equation. So you can see in this skeletal equation, there was only 1 hydrogen and 1 chlorine on the reactant side. But on the product side, there are 2 hydrogens and 2 chlorines. So to balance the equation, we had to put a coefficient of 2 in front of HCl to make sure that there are the same amount of atoms of each element on both sides of the arrow. And when you put that 2 in front of HCl, you are saying that there are 2 HCl molecules. So that's why there's 2 of this molecule on the left side. But in the end, notice that on each side of the arrow, you have 1 red sphere, 2 blue spheres, and 2 green spheres. So you'll have the same number of atoms on each side. All right, so you have 3 examples here. What I'm going to do now is switch over to my document camera so I can show you how to balance those equations. Now I think this is the first worksheet. It is, yes, this is the first worksheet in your Unit 6 packet. So I'm going to do a few of these with you, and you'll notice that number 1, number 2, and then down here, number 4 at the very bottom are those same examples from that slide that we were just on. So I'm going to do these with you. All right, so number 1, I'm going to start with hydrogen. I have 2 hydrogens on the left side, And on the right side, remember I'm talking about the left and right side of this yield sign. So on the right side, I also have 2 hydrogens. So this equation, or at least the hydrogens in this equation, are balanced. So now let's look at oxygen. On the left side, I have 2 oxygens. On the right side, I only have 1. So that is not balanced. Now remember what I said, you can't just add a little 2 here to make it balanced. If you do that, this is no longer water. What you've done is you have made hydrogen peroxide, which is an entirely different chemical. So we're not going to do that. The only thing you can do is to add a coefficient of 2 to the beginning. So we're putting a 2 in front of water. Now when you do that, that gives you 2 oxygens, but it gives you 4 hydrogens. 2 times 2 is 4 hydrogens. So now we have to come back over here and balance hydrogen by putting a 2 in front of it. So now we have 4 hydrogens here, 2 oxygens, 4 hydrogens, and 2 oxygens. Now you don't have to write the numbers underneath like I just did. I'm just doing that for now so it'll help you take inventory of what we have. But hopefully you'll get to a point where you can just visualize it and you don't have to write these little numbers here. All right, number 2, starting with nitrogen, I have 2 nitrogens. And then on the other side, I only have 1 nitrogen. So if I have 2 here and only 1 here, then I need to add a 2. Now my nitrogens are balanced. But when I added that 2 there, that gave me 6 hydrogens. 2 times 3 is 6. So I need to have 6 hydrogens on the left side. So what can I put in front of 2 to make it 6? Remember, we're multiplying and not adding. So what times 2 will give you 6? 3. So now the equation is balanced. Now I'm going to come back to numbers 3 and 4. I just want to come down here to the bottom and show you that last example from the slide. And I want to point out, as we go along, as I do examples with you, I'm going to point out little helpful hints from time to time that will hopefully make this a little bit simpler for you. And my first hint I want to give you is look for polyatomic ions. In this equation, you should immediately, and hopefully the parentheses give it away, you should immediately see sulfate. So I'm going to look on the other side of the equation and see if I see sulfate again, and I do. Now the reason why this is going to hopefully simplify things for you is you can just look at sulfate as a whole. So on the left side, I have 1 sulfate. And on the right side, since this is in parentheses with a 3 on the outside, I have 3 sulfates. So rather than looking at sulfur and oxygen individually, I can look at sulfate as a whole. If I have 1 on the left and 3 on the right, I'm going to fix that by putting a 3 in front. Now my sulfates are balanced. Now remember, after I added that 3, not only did it affect sulfate, it also affected hydrogen. So there were 2 hydrogens, now there are 6. So on the right side, I look at hydrogen and I want to make that 6. 3 times 2 is 6. And then lastly, I need to balance aluminum. I have 2 aluminum on the right, and I need to have 2 aluminum on the left. So now it is balanced. Now, if the whole sulfate thing confused you, you can also look at the atoms individually. When we put this 3 in front, that gave us 3 sulfurs, and that gave us 12 oxygens. On the right side, remember this 3 is distributed to everything within the parentheses. So we have 3 sulfurs, 3 times 4 is 12 oxygens. So it's always a good idea to go back through and check to see if everything balances. All right, now I'm going to go back up to the top and do a more challenging problem with you. That's number 3. we will eventually learn